What is this shape? Is it a quadrilateral? Is it a trapezoid? Is it a parallelogram? Is it a kite? Is it a rectangle? Is it a rhombus? Or is it a square? Well, actually, all those names are correct except for a kite. This DMT insight is about how we teach quadrilaterals. And when we focus on the name, that's when we have some incorrect thinking happening. So it's not necessarily the kid's fault, but it's how we present things in curricular resources and what we say as teachers. So let's talk about that. So the research talks about prototypes. And what we do is we have these typical, this is what a square looks like, this is what a rectangle looks like, this is what a parallelogram looks like, this is what a trapezoid looks like, this is what a rhombus looks like, and this is what a square looks like. And then maybe we talk about a kite, sometimes we don't, and just what is a quadrilateral. So our goal is to go beyond just recognition and focus on reasoning. Now, why is that important? Because I, as a high school teacher, when I was teaching algebra, and then I started working with elementary teachers and students, I found something that was just shocking. I think about shapes as lines intersecting in space, and then as I go into elementary, everything is just naming very specific looking shapes. That leads into incorrect or sometimes just misconceptions or lots of tears when kids hit Algebra 1 and geometry, because teachers are asking them to think through these requirements, not just naming. So we're going to try to start this earlier. How do we do this? The fix is really thinking about lines. So what we have here are stir sticks, wooden stir sticks. And we'll put a link to Amazon links. You can get these really cheap. They're amazing. But how we should be thinking about shapes, in this case quadrilaterals, is a line in space and another line intersects it. So then if you have 4 lines and they all intersect, creates a closed region or space inside, that is a quadrilateral. Okay, now we can be very specific. So we're going to build a square. So we're going to have the 2 lines in space that are parallel, 2 lines that are parallel, and they cross. But what a square is, we want to focus on 4 right angles and 4 congruent or same length sides. That's the definition of a square. Then if this is what I like about the stir straws, all we have to do, and we work with kids doing this all the time, starting in 2nd grade, you just shift, keep that parallel, and if you keep shifting it out, you've created a rectangle. So what is the definition of a rectangle? So we often hear it's 2 long sides, 2 short sides. I'm already shaking my head. That's not true. A rectangle's definition is 4 right angles. So whether it's here, where it's square, that is a rectangle. You can move it this way, so it's longer here. That's a rectangle. You can move them in, so it's skinny here. That's a rectangle. They're all rectangles. So that gives kids a very different way of thinking about a rectangle. Now, if we go back to the square, and then we just rotate so that there's 2 parallel, but they're not 90 degree, that becomes a rhombus. So a rhombus is only 4 congruent sides. That's all we worry about. So is a square a rhombus because it also has 4 congruent sides? Yes. So a square has multiple names. A square is also, I like doing the Oscar Mayer song. Yes, square is the first name, but it's square, rectangle, rhombus, or the other way around. It's got those 2 middle names there. Okay, now we can go back, and if I'm at the rectangle, now if I shift and make that parallel, we have a parallelogram. So then a parallelogram's definition is just 2 lines in space, 2 lines in space that are both sets are parallel, they intersect. So then that's a parallelogram, but that also, the rhombus, the square, and the rectangle are also parallelograms. So that's an extra name for them. Now, if I just pull off 1 set of parallel lines, and I'm just leave 1 set of parallel lines. Now, if I can place these other 2 lines to intersect anywhere. So a lot of times we have this prototype, this is another misconception, we always show the trapezoid as the pattern block, so it always looks like that shape. And that's not always true. I can move any of these 2 in any shape. I could have it here be a right angle, this one not. Could be. All of these are trapezoids. Now, by the way, if you Google this, you're going to get 2 different sets. This is called the inclusive set. That's what most state testing use, is a trapezoid has at least 1 set, which means all those other shapes I just named are also trapezoids. So a square now has many names. So trapezoid doesn't matter any of these 2. one set at least, and everything else is a trapezoid. Okay, now, if none of the shapes, none of the sides are congruent, there's no parallel, then that is just a quadrilateral by itself. And sometimes we skip that, but just 4 lines, if it doesn't have any of these special classifications, is a quadrilateral. Now there's one that's kind of outside these over here, and that is called a kite. And that's when you have these intersecting here, and it kind of looks like a rhombus. They're coming down here as well, but these 2 adjacent sides are the same, and these 2 adjacent sides are the same, but they can't both be the same. That would be the rhombus, and so they say it's not inclusive at this time. So then the kite has the 2 longer, 2 shorter, but it also could be 2 shorter here, longer, and then you could also put them in here and it gets inverted. So it's an inverted kite or a concave kite. So that leads to the 7 different quadrilaterals. So the importance of this thinking is changing our teaching to focus not on that recognition, but on reasoning. Okay, so as we're teaching, there's 4 things that you're going to be thinking about originally. Number 1 is we're going to use lines in space. Number 2, we're going to be asking what are the requirements for this shape? And 3, does it have multiple names? And 4, include all the kind of weird looking shapes, the non-prototype shapes. And also rotate them, because a lot of times when you take that square and you rotate, another thing we say is like, oh, now it's a rhombus or a diamond. It's not a diamond, that's another DMT insight if you want to look at the correct language for that, where the word diamond even came from. Really important is like a square. So one of the things that I like to do, warm up with kids in K5. And so we'll say, okay, so we're going to create a shape here. So if I take this shape here, take my fingers here, 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 here. What shape did I create? Square, kids say grab it. And so we'll take here and we'll say, well, what if you turn it like this? What is it? And some kids will say, nope, it's still a square. It's always a square. What if I put it on top of my head? What if I put it on the ground? Still a square. Then you can take that. It's really fun to do this with kids. What if I take it like this? Oh, a rectangle. Yep, back to a square. You can push it in, a rectangle. Bring it back to this rectangle here. Turn it. And a lot of them will say parallelogram. So there's kind of some fun things you can do with the kids. Another thing is just like now when you're looking, if you're thinking about lines in space, now you can, oh, we're outside. And you can see different lines and how they intersect. So there's stuff all around us, the windows. Those are all lines, and that creates these different quadrilateral shapes. So be looking for those type of ideas as well. So we're going to try to get rid of the way we have taught shapes, quadrilaterals, leads kids to misconceptions. And so the fix is to move away from prototypes and start focusing on lines in space. So this was an interesting DMT insight. We'd love to have your comments. Please share this with others, like it, and follow us on all social media. And we'll get kids to be moving away from passive learners and being much more active learners, so we're actually prepared for high school mathematics.